about innate immunity. So first of all, we will start with that what is innate immunity. That type of immunity basically which is present along with us since our birth and is inherited from our parents. For example, say skin, right? Skin is present since our birth, and it is that kind of layer which is protecting us from every kind of foreign invader, whether it is bacteria, virus or any kind of foreign invader, and it is present from our birth, right? This innate immunity, sometimes it is also called as native immunity. Why native immunity? Native means something which is belonging to you. For example, if I say I am native of India, I am native to India. In similar way, this innate immunity is called as native immunity because it is present with you since your birth. Not only skin, for example, HCl, hydrochloric acid, which is present in our stomach. It is also kind of protecting us from growth of harmful microorganisms because it is acidic in nature, and it is also present from our birth. If we say WBCs, white blood cells, which are also called as leukocytes, they are the cells which are actually the soldiers of our body. Like soldiers, they protect us at border. Similarly, these cells, they protect our body from any kind of foreign interference. And these cells are also inherited from parents only. So these are the different examples of innate immunity providing cells or chemicals, you can say. And one more thing, any kind of foreign chemical, bacteria, virus or any kind of external chemical, in technical terms, in immunology, we will call it as antigen. Okay, so in future in this video, if I use term antigen, it means any kind of foreign invader. Innate immunity is basically non-specific in nature. Non-specific. Why it is non-specific? Because it can act on wide variety of microorganisms. It will prevent wide variety of organisms from entering our body. It will refrain them. How it is acting on wide variety? Again, I will take example of skin. Skin is preventing every kind of bacteria, virus to enter our body. It is not saying, skin will never say, no, I will only prevent this virus from entering your body. It never does that. So it is basically trying to protect your body from every kind of bacteria, virus, or you can say antigen. So that is why we say that this native immunity, or you can say innate immunity, nate means birth. So the type of immunity which is present since your birth, it is having very broad range, or we can say it is non-specific in nature. Why? Because it does not have any kind of specificity in its action. And very important thing, after innate immunity, its role will be played by acquired immunity. Not its role, basically its function will be taken up by acquired immunity. Actually what happens, this innate immunity provides us first and second defense line. It is forming first and second defense line of our body. First defense line, skin is first defense line which protects us. If first defense lines fail, second defense line will play its role. Example, I told you hydrochloric acid, or you can say bile juice secreted by our liver. It is also alkaline in nature, prevent growth of microorganisms and forms second defense line. After innate immunity has played its role, now it will ask acquired immunity, and that acquired immunity forms third defense line of our body. Actually, we have in total 4 defense lines in our body. That third defense line, this innate immunity will then ask third defense line of our body that now it's your turn to kill the bacteria. So that third defense line, or you can say acquired immunity, will start to produce antibodies, because in acquired immunity we will talk about antibodies, or you can say killer cells. There are different types of cells which are present in acquired immunity. We will talk about them in detail. So what will happen? Antibodies will start to produce. To a particular antibody, particular antigen is present. That is, if there is a particular antigen, in response to that particular antigen, antigen, a particular antibody will be formed, because both the antigen and antibody, they have specific receptors on their surface, and only those receptors can recognize each other. Because of this recognition, or you can say because of this receptor mediated reaction, in response to a particular antigen, a particular antibody will be formed. So this is how whole scenario of immunity is working, that when first and second barrier of innate immunity will ask acquired immunity, or will hand over its role to acquired immunity, which is third defense line, antibodies, they will start to produce antibodies, they will start to kill antigens. And we know that actually antibodies, they are nothing, they are proteins, and those proteins, they can easily act on antigen and can kill it, right? How antibodies are produced, that is a whole different mechanism. So in innate immunity, there are four kind of barriers present. Four barriers, which are physical barrier, physiological barrier, cellular barrier, and cytokine barriers. These four barriers, they will collectively help us to fight with any kind of foreign invader. So only innate immunity is providing us four kind of barriers. If these four barriers fail, or you cannot fail after they have performed their function, after four barriers have performed their function, then acquired immunity will start to play its role. So you can see how strong our body is. How? First of all, we will deal with physical barrier. In physical barrier, we will deal with skin. I already told you one thing, that skin is outermost layer which protects us from any kind of foreign invader, and it will act on wide range of antigens. It can prevent every kind of bacteria, virus from entering our body. So it is basically refraining any kind of foreign intrusion. And one thing which is very important is that the outermost layer of skin, which is providing us protection, is called as stratum corneum. This is very, very important from multiple choice questions point of view. Okay, stratum corneum. This is the outermost layer of skin which provides us protection. If we see its transverse section, it appears somewhat like this. It is a layer of epithelial cells basically. You also see that if your skin is bruised somewhere, if your skin is peeled off somewhere, then you get easily prone to infection. You will catch infection easily in that region. Microorganisms, they will start to grow in that region because skin is not present in that region now, and that is why we say that skin provides us protection. Next, in this physical barrier only, we will talk about mucus secretions. Mucus is a kind of slimy secretion which is present throughout your respiratory tract, even in your nose. As it is slimy, it can easily entrap any kind of antigen which will enter our body, so it will refrain it from entering further deeper respiratory tracts like lungs and alveoli. They will be protected. Now we will talk about physiological barriers. Actually, physiological barriers, physiological means any kind of barrier which is present in our organ systems like digestive system, respiratory system, liver, okay? And in these physiological barriers, we have HCl, hydrochloric acid. This hydrochloric acid is very acidic in nature. As it is acidic in nature, so it will prevent growth of microorganisms. Next, we can talk about bile juice. Bile means always liver. Wherever you read word biles, it is always associated with liver. So bile juice is alkaline in nature. Like HCl was acidic in nature, bile juice is alkaline in nature. It will also prevent growth of microorganisms. Sweat. Okay, sweat is having certain ions, certain salts in it, so it will also prevent growth of microorganisms. Vaginal secretion. It is a kind of mucus and slimy secretion which is secreted by female genital organ, that is vagina. So it also protects vagina from harmful microorganisms, from growth of harmful organisms. Then is lysozyme of saliva and tears, and this is very, very important. Again, actually this whole topic is very important, okay? So lysozyme of saliva, you know what, your saliva is having an enzyme which is called as lysozyme. And not only saliva, even our tears, they have this enzyme which we call as lysozyme. And this lysozyme It kills bacteria. But how it kills bacteria? You know what? It breaks down the cell wall of bacteria. So if your question comes that which part of bacteria is acted upon by lysozyme, your answer should be cell wall of bacteria. This lysozyme will break down the cell wall of bacteria and ultimately, eventually it will kill our bacteria. Next is, and it is also present in tears. Next is urine. Again, urine is having certain kind of salts, certain kind of ions. So it protects male's urethra because urine is sticking to urethra, right? Next is cerumen or earwax. Earwax is the wax which is present in our ears. It is also called as cerumen. It is also protecting entry of any kind of harmful microorganisms. So in physiological barriers, two things are very important, two questions. First one is lysozyme, which I told you that which part it is acted upon by lysozyme, and second one is stratum corneum, outermost layer of skin. Now we will talk about cellular barriers. Cellular barriers, out of these four barriers, cellular barriers are most important. Okay, so in cellular barrier we will talk about different kinds of cells which provide us innate immunity and which are present along with us since our birth. For example, leukocytes. We know that leukocytes are also known as white blood cells, WBCs. And there are different type of WBCs which provide us immunity. Then we will talk about natural killer cells, which are NK cells. We will take each of them, leukocytes, NK, antigen presenting cells, each of them we will take in detail. Okay, so don't worry about these. Cytokine barriers. These include various chemicals, interferons, lymphokines. Actually, if these cellular barriers, they are clear to you, then it will be easier for me to explain these cytokine barriers also. Start with cellular barriers. And in cellular barriers, first of all, we will talk about leukocytes, which are also called as white blood cells, and they are soldiers of our body. They are protecting us from different kind of infections. And you know what, in leukocytes we will talk about monocytes and neutrophils. Actually, leukocytes, they are of many types, and all types they provide us protection. Mainly they are of two types, agranulocytes, granulocytes. These agranulocytes are further of three types, eosinophils, basophils, neutrophils, and these types which I am writing, they have nothing to do with innate immunity here, but I am just telling you, basically we will deal with neutrophils in detail. Okay, eosinophil and basophils, they also provide us innate immunity, but neutrophils are the main. Okay, and if we talk about granulocytes, they are also further of two types, which are monocytes and lymphocytes. And monocytes are the type of WBCs which again provide us innate immunity, and we will take up these monocytes and neutrophils both in detail. Lymphocytes, they are very important, but they play their role in acquired immunity. These lymphocytes are further of two types, B lymphocytes, T lymphocytes. So we will talk about them also later on. And we cannot say that these EO and BASO, they are not participating in innate immunity. Actually, they are participating, but not as much as role is played by neutro and monocytes. So first of all, we will talk about monocytes. Monocytes, they are the largest WBCs. Very important multiple choice question, that which WBC are largest, which WBCs are largest. So your answer should be monocytes. Second thing is that these are phagocytic in nature. Again, very important. What does phagocytic means? For example, if this is our monocyte, okay, and this is suppose this is our antigen, any kind of foreign invader. So what will happen when this antigen will come in vicinity of this monocytes? This monocyte will start to invaginate its plasma membrane, something like this. So antigen will be entrapped in this pocket-like thing which is formed. Then there is a phagosome which is present inside these monocytes. cells. Phagosome is basically digestive vacuole. Okay, and this digestive vacuole is having digestive enzymes which are called as lysozymes. These lysozymes, as their digestive enzymes, so they will help in, you can say, digestion. This antigen will move inside this phagosome, and these lysosomes present inside this phagosome, they will digest this antigen, and ultimately this antigen will be digested and it will be killed, right? So this is what is happening. This is how phagocytosis happens. And one more thing about monocytes. These monocytes, in particular conditions, in specific conditions, they give rise to another kind of cells which we call as macrophages. Again, very, very important. These macrophages, as they are formed from monocytes, so we can say that these macrophages, they are also type of WBCs, okay? And third thing is that I told you that there are antigen presenting cells also. These antigen presenting cells are dendritic cells, B lymphocytes, and macrophages which are formed by monocytes. They are also a type of antigen presenting cells. So these are type of, you can say, WBCs also, or you can say they are type of antigen presenting cells also. But three things which you have to learn about these monocytes is that they are largest WBCs. Second thing is that they are phagocytic in nature, and third thing is that they give rise to another type of cells which we call as macrophages. Next thing, I told you that we will take up neutrophils. Neutrophils, again, they are phagocytic in nature. Phagocytic, similarly, the same way the monocyte was doing, they will also do phagocytosis in similar way. What will happen when antigen will come in vicinity of this neutrophil? They will form a pocket-like structure, and antigen will be entrapped in this pocket-like structure. Later on, antigen will move to phagosome, which is a digestive vacuole, and in that digestive vacuole is present lysozymes. These lysozymes are digestive enzymes, and so they will help in digestion of the antigen. This is how neutrophils work. And second thing which is very, very important again, that these neutrophils, they are multi-lobed. For example, if this is our neutrophil, they will have multi-lobed nucleus. So they have multi-lobed nucleus, and due to this multi-lobed nucleus, they are also called as polymorphonuclear leukocytes, PMNLS. What is the full form of PMNLS? Polymorphonuclear leukocytes. Okay, this is again very important. So three things about neutrophils: multi-lobed nucleus, so-called polymorphonuclear leukocytes, and third thing, again similar to monocytes, they are phagocytic in nature, have lysozymes, phagosome, and so on. Next, we will talk about antigen presenting cells. And one thing which I already told you, that eosinophils, basophils, they are also involved in providing you innate immunity. But we took up these neutrophils and monocytes in more detail. And to explain these antigen presenting cells which are present in cellular barrier only, I will have to explain you about lymphocytes, which I told you that they are part of acquired immunity actually. Okay, but if you know about these lymphocytes in precise manner, then it would be easier for me to explain you these antigen presenting cells. So first of all we will learn about these lymphocytes. They are basically are of two types. Lymphocytes, you know that they are type of agranulocyte leukocytes. Okay, so these lymphocytes, they are of two types: B lymphocytes and T lymphocytes. These T lymphocytes, they are actually further of four types, but we will talk about two types here only. These four types I will take in acquired immunity in detail. Okay, these types are CD4 and CD8. CD8 T lymphocytes, they are also called as helper cells, and CD4 T lymphocytes, they are also called as killer cells, or you can say cytotoxic cells also. And third type is memory T cells, and we will take these types later on in detail. Okay, but now just concentrate on CD4 and CD8. CD4 called as killer cells, CD8 is called as helper cells. And second type is B lymphocytes. So So lymphocytes are basically of two types, B, T. T is further of four types, but we are taking CD4 and CD8 here. So what happens that in case of acquired immunity, I told you that in response to a particular kind of antigen, in response to a particular kind of foreign invader, a particular antibody is formed. So how is that antibody formed? See what happens. Suppose this is antigen and this antigen enters in our body. That signal will be transmitted by these helper T cells, or you can say helper T lymphocytes also, you can say CD8 cells also. It will be transmitted by helper T cells to another type of lymphocytes which we call as B lymphocytes, and after receiving signal, B lymphocytes, they will start to divide and form plasma cells. Basically, large number of plasma cells will be produced. You can say a large clone of plasma cells is produced. These plasma cells, they will further divide to form two types of cells. First one is antibodies, and you know what is the function of antibodies, and second one is memory T cells. Actually, I told you that there are four types of T lymphocytes. First one was CD4, second is CD8, and third type I told you memory T cells. So this is how memory T cells are formed. And we will talk about the function of these memory T cells. These memory T cells, basically they store the information of first encounter of pathogen with our body. That how, that when for the very first time when pathogen entered in our body, then how our body dealt with that pathogen, how our body, how antibodies killed that pathogen. So they store all that information in themselves. So if that pathogen, if that bacteria enters our body for second time again, then these memory T cells, due to their stored information inside them, body will start to act very faster. Its second response, or you can say its second response to that bacteria to kill it will be much faster than first one. Because now memory T cells have all the stored information, and our body by now it knows that what kind of antibody I will have to form or what kind of action I will have to take. So this is how memory T cells, they are helping. They are storing all the information of first encounter of pathogen with our body, so that if that pathogen enters our body again for second time, it would be easier for our body to fight due to all the stored information, because by now body will know that how to act. And antibodies, you know, they are proteins. Antibodies are what? They are proteins, and they are of many types, IgG, IgA, we will talk about them, okay? Antibodies, they are different types of proteins, and in response to a particular kind of antigen, a particular antibody will be formed. Why? Because both antigen and antibodies, they have certain kind of receptors. If antigen is having this kind of receptor, antibody will also have this kind of receptor, so that they can get interlocked and they can, this antibody can act on this antigen. Okay, so this is actually receptor mediated reaction. So now, by now you should know that what is happening if antigen enters our body. I am repeating again, if antigen enters our body, signal will be received by helper T cells, which are also called as CD8 cells. They will transmit that signal to B lymphocytes. B lymphocytes, they will divide to form plasma cells. Plasma cells are produced in large number, and they will further divide to form antibodies and memory T cells. Memory T cells, they will store the information of first encounter of pathogen with our body, and antibodies, they will start to act on that antigen. But there is one problem, okay, that I told you these helper T cells, they send the signal to B lymphocytes that an antigen has entered our body. But these helper T cells, they cannot easily recognize this antigen. That is the problem. They require a specific type of cells. They require particular kind of cells which will present antigen to them like this. Suppose this is a cell, okay. So this cell, this particular cell, it will have to represent antigen like this to helper T cells. And so it is, what is this cell doing basically? It is showcasing, you can say it is showing this antigen to helper T cells, so that it can recognize the antigen easily and can further transmit that signal to B lymphocytes. So they are basically making it easier for helper T cells, you can say, by showing that antigen on their surface. So that is why these cells, they are called as antigen presenting cells, or in short form you can say they are called as APCs, and they are of three types: dendritic cells, macrophages and cells. They are helping helper T cells, or you can say CD8 cells, by showing antigen on their surface like this. For example, see, like this. They will show this is antigen. This is how they are showing the antigen to CD4 cells, or you can say helper T cells. And later on you know what helper T cells they will do. But the question arises, how is this thing happening? Okay. So let us take example of dendritic cells. Why these are called as dendritic cells? Because they have structure like this, like dendrons of neurons. Okay, they are having branched extensions like these. So what will happen? When an antigen will enter in vicinity of these antigens, they will start to perform in vicinity of this dendritic cell. They will start to perform phagocytosis. They will form a pocket. In that pocket, antigen will be entrapped. Later on, this antigen will enter phagosome in similar way like monocytes. Okay, and this antigen will be digested in this phagosome due to presence of enzymes which we call as lysozymes. After digestion, the peptide which is produced, peptide is chain of amino acids. Peptide component of that antigen will be presented on outer surface of these antigen presenting cells. Okay, so this is antigen, not whole antigen. You can say this is the peptide portion of that antigen, and this receptor which is showing that antigen to the helper T cells is called as major histocompatibility complex 2, MHC2. We call it as major histocompatibility complex 2. So what is this complex? Actually, this is also a proteinaceous structure, or you can say this is a proteinaceous complex which will help protein in itself, and it will showcase this protein to helper T cells. But as this is receptor, so there will be receptors present on surface of CD4 cells also. You can helper T cells also. Okay, CD4 and helper T cells both are same thing. And those receptors which are present on surface of helper T cells, they are CD4. That is why we are saying it as CD4. That is why we can say helper T cells as CD4 cells, because they have a receptor on their surface which we call as CD4, and this CD4 is glycoprotein. So this receptor will easily identify this antigen which is present on the receptor of this antigen presenting cells, which is dendritic cells, and this receptor, or you can say this proteinaceous structure, this complex is called as major histocompatibility complex 2. So MHC2 and CD8, not CD4, sorry, I'm really sorry, it is CD8. Okay, CD8. We call helper T cells as CD8 cells. Okay, MHC2 and CD8 cells, they will recognize each other, and after they present this antigen to helper T cells, they will transmit this signal to B lymphocytes. These B lymphocytes, they will start and divide to form plasma cells. Plasma cells will again form what? They will form large number of antibodies. So this is how acquired immunity, or you can say this is how whole thing is working. To make antibodies, helper T cells need to receive the signal, and to receive that signals, these antigen presenting cells, they are representing this antigen on the outer surface of their cell, so that T cells, they can easily recognize the antigen. But there is one more thing. This major histocompatibility complex 2 is not only of one type. It is having two types, that is MHC2 and MHC1. Okay, actually this is not part of antigen presenting cells, but I am telling you just for your knowledge that it is of two types, MHC2 and MHC1. MHC1 is present in all type of cells of our body. Any cell of our body which is nucleated, which is basically having nucleus inside it, is having MHC1 on its surface. Okay, but MHC2, it is only present on surface of these three types of cells which are antigen presenting cells. Because if MHC2 is present, it starts to present on every type of cell, then every cell will start to give signal to helper T cells, because every cell will now start showcasing this antigen to helper T cells, and then every cell can be APC. But this is not possible. So actually this kind of MHC1 is showcased by those type of cells which are very highly infected. That is useful in this MHC1 is useful in that case. So what will happen? Suppose this cell is having many antigens inside it. So it is highly infected. It is having many viruses, bacteria. So this cell knows that now I need to be killed. So this cell will start to send signals to different you can say it will start to send signals to killer cells. Killer cells were actually CD4 cells, right? I told you that T lymphocytes are of two types, CD4 and CD8. CD8 were helper T cells and CD4, they are killer T cells. So what will happen? Due to presence of MHC1 on this complex, MHC1 complex on this highly infected cell, it will start showcasing the antigen. It will present antigen on its outer surface. This antigen will be recognized by killer T cells, which we call as CD4 cells, which are type of T lymphocytes only. Why these cells are called as CD4 cells? Again, because these killer T cells have a glycoprotein on their surface which is called as CD4. Like we were saying that helper T cells, they are called as CD8 because they have glycoprotein CD8 on their surface. Similarly, they are called as CD4 cells. These CD4 cells, they will easily recognize this antigen, and what they will do, they will start to produce a kind of protein which we call as perforins. And as the name suggests, these perforins, they will start to produce, or you can say form pores in this highly infected cells. And from these pores, water will start to enter inside the cell, and this cell will ultimately swell up and burst. So this is how very highly infected cell is killed, because ultimately it is burst with the help of killer T cells because they are producing perforins. But how these killer T cells, they recognize these highly infected cells? Because this cell is having MHC1 on its outer surface, like every nucleated cell is having, every normal cell is having. This antigen will be presented to these CD4 cells. There will be recognition between them, so it will start to form pores in this cell, and ultimately it will burst due to swelling. So actually this had nothing to do with this antigen presenting cells, but I told you because you should know type of major histocompatibility complex, that there are of two types. Okay, so I told you about dendritic cells. If we talk about macrophages and B lymphocytes, they are also antigen presenting cells. What they do? Similarly, they will, but their structure is different. Macrophages, you remember how these macrophages, they are formed? I told you that this question is very important. Macrophages are produced from monocytes. These macrophages, they will also have MHC2 on their surface. They will also showcase antigen. Okay, antigen, which is basically peptide. Why peptide? Because all the antigen is digested in this organelle which we call as phagosome. Due to phagocytosis, only peptide will be left. This peptide will be showcased to CD8 cells, which are helper T cells. These CD8 cells, they have glycoprotein something which is called as CD8 on their surface. So recognition reaction will occur. These helper T cells, after recognizing antigen, they will start to send signal to B lymphocytes, which will then divide to form plasma cells and antibodies, and so on. And actually one thing more, you can say that after these T cells, they recognize these antigens on surface of macrophages or any kind of APCs, release of certain kind of chemicals occur. And those chemicals, they are called as cytokines. Actually, I told you there are 4 kind of barriers, cytokine barriers. I said that if APCs are clear to you, then you can easily understand cytokine barriers also. So these cytokine chemicals, they are released. Those cytokine chemicals, they will help in proliferation of more and more helper T cells. They will division, they will help in formation of more and more helper T cells. If more and more helper T cells are formed, more will be signal transmitter to B lymphocytes. More is a signal transfer to B lymphocytes. More will be the formation of antibodies. So this is how whole scenario is working, and this is what is the role of, you can say, cytokines. And cytokines are released by different cells. For example, cytokines which are released by lymphocytes, they will be called as lymphokines. Which are released by dendritic cells, they will be called as dendrokines. Okay. So this is how it is working. If you talk about B lymphocytes, you will say that B lymphocytes are present here. How can these be antigen presenting cells? See what happens. One thing, see, suppose this is B lymphocyte. Again, antigen comes. That antigen is digested in phagosome. Peptide part, peptide component of that antigen will be showcased to helper T cells, that is CD8 cells, which will result in secretion of chemicals which are called as lymphokines. Those lymphokines, they will help in differentiation of, or you can say formation of more and more helper T cells. As more and more helper T cells are formed, they will transmit signal to other kind of B lymphocytes, to other B lymphocytes which are left. Okay. So B lymphocytes, they are acting as APC also, and they are other B lymphocytes which are left, or which are other lymphocytes which are still present in our body and which are not acting as APCs. Those B lymphocytes, they will receive signal from T cells and they helper T cells, and they will start to form antibodies. And antibodies, you know what they do, they will start to act on antigen. So I hope this whole thing is clear to you that what is happening. I am repeating again for you guys. See, MHC complex is of 2 types, MHC1 and MHC2. MHC1 is present in every kind of cell which is nucleated. MHC2 is however only present in antigen presenting cells. This MHC2 will showcase antigen to helper T cells which are having CD8 glycoprotein on their surface. After recognition, helper T cells, they will start to send signal due to release of chemicals which we call as cytokines or lymphokines, kinins. They will start to send signals to B lymphocytes, which will then divide to form plasma cells. Plasma cells will form antibodies and memory T cells. And if we talk about MHC1, which is present on surface of nucleated cells, they will showcase antigen and to a certain type of cells which are also type of T lymphocytes, but they are called as killer cells or CD4 cells. Sometimes these cells are also called as cytotoxic cells. These cells, they will release perforin proteins which will kind of create pores in that highly infected cell which is having so many antigens inside it. Due to pores, water will start to enter inside cells, and ultimately due to swelling, that cell, it will burst up. So this is how MHC complex is working and antigen presenting cell is working. So your 2 things are covered. Major histocompatibility complex, which are very important, they are also covered, and APCs are also covered. So next we will talk about, and one thing, yeah, I told you that these killer T cells, they are called as CD4 cells and they are also called as cytotoxic cells. And one thing more, that I told you these showcase peptide component of antigen. But these are showcasing this component to helper T cells, and these T cells, helper T cells, or you can say lymphocytes, they are actually present in lymph of our body. Lymph is a kind of fluid. Okay, you can say, for example, blood is also a fluid, lymph is also a fluid, and in that fluid, lymphocytes, they are circulating. So these antigen presenting cells, firstly they will have to move to lymph Then after moving to lymph, there they will showcase this antigen to lymphocytes, that is helper T cells. So this is another thing. And yes, now we will talk about mast cells. Okay, but firstly I will have to erase. Mast cells are the cells which release a chemical which we call as histamine. This histamine will result in dilation of blood vessels. As blood vessels are dilated means there will be increase in diameter in that area. More blood will travel to that area where there is dilation of blood vessels. Okay, and as there is more blood traveling to that area, there will be reddening of that area. So it will start to show allergic symptoms. You can say your eyes, they will start to get red. Your skin, it will start to show red sores on it. Okay, so this is how it shows allergic reactions. And what is the significance of this, that more blood is traveling to allergic area? Actually, if more blood is traveling to allergic area, that blood will carry macrophages along with it. And you know what is the function of macrophages then. These are type of APCs which will then showcase their antigen to helper T cells. Helper T cells will again release the signal to B lymphocytes. B lymphocytes will then form antibodies. Antibodies will then kill antigen in that inflammatory area or in that infected area. So basically, why does red sores happen on that area which is infected? Because of dilation of blood vessels due to release of histamine by mast cells. Another thing I told you that we will, in case of cellular barriers, we will talk about is fever. Actually, fever is sometimes useful. Okay, how if you have very less fever, a little bit fever, then it means your immune system is activated. It is more activated and it can fight with bacteria and viruses more easily now. So, but if we say that yes, our body is having very high fever, obviously that is harmful. But a very slight fever is useful to your body because it kinds of, you can say, activates your immune system. Okay, so this fever, and why does this slight fever occurs? It occurs in case of slight infections in your body. For example, due to entry of any kind of bacteria or due to release of certain chemicals which are harmful for your body, and those chemicals or those bacteria, they will basically reset the thermostat of your body. Thermostat is hypothalamus. You know that thermostat which maintains our body temperature is hypothalamus. However, these chemicals which are harmful for our body, or you can say any kind of foreign invader which has entered our body, they will reset the temperature of hypothalamus. So you will start to have fever. But that slight fever is useful for you. I already told you. Next thing is that I told you that we will talk about NK cells in cellular barrier. NK cells were natural killer cells. These natural killer cells, they are very similar to CD4 cells, which were killer T cells, which were type of T lymphocytes. These natural killer cells, they also produce protein which we call as perforins. These perforins then will create pores in the body of antigen or any foreign invader so that water will enter, and ultimately this cell will burst because it will swell due to entry of water. So this is how natural killer cells are working. And last were cytokine barriers. I already told you about cytokines, that these are certain kind of chemicals released which help in more and more formation of helper T cells, and if more and more helper T cells or CD8 cells are formed, more will be signal transmitted to B lymphocytes and more will be formation of antibodies. So this is all about innate immunity, and not only innate immunity. I covered many major topics in this. Major histocompatibility complex, about this complex. You can say about APCs, antigen presenting cells. I also covered this topic. Another important topic we covered about different types of leukocytes, granulocytes, agranulocytes. Okay, and we also covered little bit of acquired immunity in this. You can say that overview of acquired immunity is also clear to you in this video only. So in next video, I'll try to take up acquired immunity in detail. Okay.